Let's talk a little bit about capacitance. A capacitor is a device in a circuit that is used to store charge. Basically, all capacitors are about the same. What they are a couple parallel plates. They have some area. They're separated by some distance. And basically, it's just area that charge can settle on, right? They use capacitors for to smooth out. So if you have like a rippling voltage, you can have the capacitor charge when the voltage is high and discharge and fill in the ripples. You can use capacitors for like a flash in a camera or a pulsed laser, famously, right? Gauss guns use them, right? You charge up the capacitor over a long period of time, and then you use the energy in the capacitor suddenly. But anyway, it's kind of cool. This is the symbol for an ordinary capacitor. Electrolytic ones look like this. They've got a curvy side. I'm pretty sure that's the positive side and the negative side. But generally, capacitors are not non-electrolytic capacitors. Regular ones they can be hooked up anyway. They don't have a polarity to them. And the unit of capacitance is a coulomb stored per volt of potential. That is a farad, and a farad is just a giant unit. Typically, we talk about microfarads, right? So 10 to the minus 6th farads or picofarads are typical units you'll see in circuits. Pico is 10 to the minus 12th. This is 10 to the minus 6th, of course. And if you look at the formula for the charge, if we solve this for charge is how big the capacitor is times the pressure you've used to push that charge onto the plates, right? And it has to do, and we'll talk about that when we look at the formula for how this works, but it has to do with the area, it has to do with the distance. I don't think there's anything else. Let me show you a picture of what capacitors look like. So these are electrolytics, right? The big ones there. So that's 4,700 microfarads, right? Notice that they also have a rating for the voltage that they can withstand. This is 35 volts. That's 35 volts. This one's 16 volts. That has to do with how well insulated they are. These ones are probably picofarads. These guys are microfarads. Okay, MFD, like that. You can see the microfarad right there. These things typically are higher voltages, so 100 volts, 500 volts, 1,000 volts. And these are variable. Okay, variable capacitors. Typically those are used in RF circuits to tune up a signal or something like that. And I've just told you everything I know about that. Okay, let's look at an example problem here. So we're going to use our formula that C is Q over V, and we want to find out the voltage, right? So V is going to be what, Q divided by C. Now we got to figure out, okay, so the capacitance, CCD pixel, this, by the way, is a light sensor. Each little pixel is hit by photons. When a photon hits it, it displaces an electron to another level. They act like capacitors. They store up charge. The more photons that hit them, the more charge they have. And they use them. I don't know if iPhones use CCDs. They probably don't. But it's a somewhat, I think it's a somewhat old type of optical sensor used in cameras. Okay, so let's, our capacitance is 1.7 times 10 to the minus 12. That's, by the way, picofarads, right? And then it has 60,000 electron charges. So we got to figure out Q. Q is 6 times 10 to the 4th electron charges times 1.602 times 10 to the minus 19th coulombs per electron, right? So let's see, 6 E4 times 1.602 E minus 19. Our charge is 9.612 times 10 to the minus 15th coulombs, right? So now we can figure this out, right? The voltage across it is going to be how much charge you have, basically divided by how much space it's got to move into, right? The capacitance of it is, you can think about that as space for charge. Okay, so 9.612 times 10 to the minus 15th coulombs divided by 1.7 times 10 to the minus 12th. And that is coulombs per volt, or farads, by the way. A farad is a coulomb per volt. So I'm going to divide that by 1.7 times 10 to the minus 12th And I get that the voltage is 0.00565 volts, which is 5.65 millivolts. And that's a millivolt is, of course, a 1,000th of a volt. So you just go 1, 2, 3. Now it's millivolts. Okay. All right.